So this is the last workshop of our series. We had three digital workshops before on the same topic. So I'm very happy to see some known names among the participants. My name is Silvia Ecclesia. I am from NTNU and I will be your chair today for the workshop. And we will discuss specifically data issues and challenges in robotics for the Agile production sector, with a particular focus on legislation and compliance with regulations especially. So before we start, a little bit about the agenda and what we will do today. So first, we will have a brief introduction of the project Robotics for EU, and we will ask you to fill a quick poll to understand what is your knowledge and expectations regarding robotics and data issues. And then we will have two very interesting keynote speeches. So the first by Atina Sakolidou from Nova University, Nola School of Law, on the criminal liability of robotics. And the second keynote speaker will be Professor Winston Maxwell, especially focusing on human oversight of AI systems and how human oversight can also be an enabler for data protection connected to data issues. Then we will have a short break, and then we will hear again from our consortium members on the RoboCompass, which is the specific tool that will come out of the Robotics for EU project. And finally have a discussion with the participants in breakout rooms and a plenary and closing session. So without waiting further, I will now just give the word to Joanna Martinera from other communication organization, LOBA, to give introduction to Robotics for EU.
Thank you, Sylvia. Hello, everyone. And it's a pleasure to be here today. Thank you for joining us on this workshop. So trying to briefly introduce Robotics for EU. Sylvia, if you could please change the slides. Thank you. So for those of you that don't know what Robotics for EU is about, I can already tell you that one of our main goals is to ensure more widespread adoption and societal acceptance of AI-based robotics. I don't know if you can hear me properly. You is saying to me that my sound is cutting. Okay, nice, perfect. The internet connection today is not that good, so I'll try my best. So our aim is to implement the principles of responsible robotics in 4 priority areas: healthcare, agri-food, agile production, and infrastructure and maintenance. And we want to create and empower a European robotics community that is made of research innovators, end-user citizens, policymakers, among other stakeholders, by raising awareness through co-creation workshops, the organization of events, but also through knowledge transfer and capacity building workshops. Today's workshop is one of those. That will allow us to transfer some of the knowledge that we have been gathering through these 3 years of projects, but also through advice by creating a set of policy recommendations on responsible robotics, by sharing good practices, and this is a never-ending circle. So we aim to create responsibility and collaboration in different dimensions, in social dimension, legal, data, cybersecurity, ethics, gender. And with that, we aim to create awareness, a greater awareness, and improved understanding of non-technological aspects of robotics. So please, Sylvia, if you could change. Thank you. And throughout these 3 years, we have been creating synergies and collaborated with other robotics-related projects, trying to build upon previous work that was done by these projects and try to exchange and transfer knowledge between us. And here are some of the examples of some projects that we have been engaging with from different priority areas, but always under the umbrella of responsible robotics. So trying to sum up, which is difficult because by now we have done plenty of things, but trying to summarize what we have been doing and what we still aim to do until the end of the project. We have analyzed the societal needs regarding the use of robotics in society, and we have reached several people and several projects. We have done interviews and surveys precisely to make this analysis. We have also trying to understand what are the needs, the wishes and concerns of citizens regarding the use of robotics by using the global say methodology, and we have reached a really good number of citizens as well. We have also created a set of sector workshops from the 4 priority areas that I've mentioned. Today's workshop is one of the final ones. And also developed co-creation workshops where we will have companies, robotics companies and end users that could exchange feedback between them. And we have also collaborated with several companies so that they could test their robotics ideas with citizens through online citizen consultations. And the results of these consultations are already available under our website. We have also, and we're still implementing and showcasing the virtual exhibition. This is a virtual gallery precisely to showcase robots from different companies and trying to bring closer citizens from robots so that they can get to know robots in events, in conferences, and in other activities. And we are still almost about to finalize our policy recommendations of non-technological aspects of robotics. It's about to be released really soon. And we are also developing Responsible Robotics Compass, also known as RoboCompass, that my colleagues will present later on. This is a self-assessment tool for companies to understand if they are complying with certain non-technological aspects related with their robots so that they make sure that they are well accepted by the society. And finally, we are trying to collect all of the resources and assets, tools and services that we have been producing over these 3 years in the AI On Demand platform. This is a platform that is being managed by the AI for Europe project that aims to gather all the information, all the resources on AI in Europe. And we are in close contact with them so that we can integrate our resources there as well. And that's it from my side. If you have any questions about us, you can always go to our website and contact us. We will be happy to help you in whatever you need. Thank you.
Thank you, Joanna. And I also, at the end of the workshop, I have a slide to subscribe to our newsletter. So if you're interested in keeping in touch and staying updated on the Robotics for EU activities, we are very happy if you want to do that. So thank you again, Joanna. And now I will just say a little bit about today's topic. So we decided to focus today's workshop, which is part, as Joanna said, of these capacity building activities on the specific area of data and data issues. And this is because it actually emerged from the previous events that data challenges are in a way, most important because they intersect with many other aspects of robotics, many other non-technological aspects of robotics. So they intersect with the human-robot interaction. So what is the data issues that emerge when the robot is interacting with humans, and especially with legal issues and how to comply with the GDPR and the regulations such as the Artificial Intelligence Act. So today we will explore a little bit through the keynote speeches, but also with the discussion in the breakout rooms, the topics of how is data collected, processed, and used, but also who is the owner of the data. So questions about responsibility and liability of how the data is collected and used. Before diving into the keynotes, however, we have a short poll that we would like you to fill in. So if you launch the poll, you would see it appear in the menu bar at the bottom of your Zoom app, and I will give you like 3 minutes to fill in the poll. It's just 5 questions to understand a little bit what is your background, but also current knowledge and understanding of what are the data issues connected to robotics at the moment. Yeah, I see some answers coming in. So it means at least that people can find the poll. Yes, thank you. Vasilis is noting that question 5 does not allow for multiple answers. So you can choose the one you find most important. And if you want to leave any comments, you want to elaborate a bit more, you can also type in the chat. And we are very happy to engage in the chat. Yeah, I mean, we can see that, or I can see at least from the results that I have here that the majority of you think that data-related issues are very important for a wider uptake of robotics. So at least it means that this is the topic that we chose for this workshop. It's quite relevant and important. And then among the measures that can be taken, I see higher involvement of workers in data management processes as one that you indicated as most important. I think that's very interesting. And users having more control over human robot systems as well. So we see how human oversight also it's important in this sense. We'll give you 30 more seconds and then end the poll. Yeah, I think we can end the poll questions. Perfect. Thank you so much for answering. And it's very helpful for us to understand also what is it before coming to the workshop, what is it already that you know and that you think are important issues related to data and robotics so that we can also take that into account in the creation and the improvement of the RoboCompass. So we are a little bit ahead of schedule, which is great. I really like that rather than the other way around. But we can start with our first keynote speech then by Atina Sakolidou, Assistant Professor in Criminal Law at Nova School of Law. And she will talk about criminal liability and robotics. So I will stop sharing my screen. And Atina, the floor is yours.
Thank you very much, Sylvia. Just give me a second to start sharing mine. Thank you for this kind invitation. Thank you for the introduction. Let me just correct, because today I'm joining from Greece, where I have recently moved and I'm affiliated with the Aristotle University of Thessaloniki, again as an assistant professor in criminal law, while still collaborating with Nova School of Law, but as a visiting senior researcher. And as Silvia has already told us, today I chose a topic that at first sight may not seem that relevant considering the general topic of this workshop, namely criminal liability and robotics. But I'm going to explain you in a while how those two may be connected, whether directly or indirectly. Starting this presentation, I feel the need to restate the obvious, that law is dynamic by nature. And if today's presentation was about civil liability or just data protection law, this wouldn't be the perfect introduction line. Nonetheless, for me as a criminal lawyer, it's quite important to start things like that, because often criminal law is considered too big to be changed, too traditional to be flexibilized, and so on and so forth. The truth, however, is that criminal law has been reshaped in the past to respond, for instance, to changes in family and social relationship. We are lucky enough to not criminalize homosexual relationships anymore in the majority of legal orders across the world. It has also been reshaped to address scientific progress nowadays. It's not a criminal offense to resort to medically assisted reproduction in order to become parents. And those are just a couple of representative examples. So the question is whether today AI and robotics in particular are calling out for yet another change, among other things, in the realm of criminal law. And allow me to say that this has already become a rather old news story, in the sense that for a couple of years now, we have started discussing about several topics that pertain to criminal law and new enabling technologies. When it comes to substantive criminal law, there has been a quite energetic debate as to whether we need a new causality theory. The inspiration platform here has been the autonomous vehicles. There have been discussions about whether we are entering an era of new offenses. The example here has been the racist chatbot. And maybe a more down-to-earth example that has to do with new duties of care. This has also been touched upon in the introduction that we attended a while ago about the interaction between human actors and robots. And this is maybe where we can detect the most direct link between this presentation and the topic of today's workshop, namely data challenges. So what if, when it comes to data processing, data use, we need to address those as a new duty of care in the era of interaction between humans and robots? Of course, challenges that are related to criminal law and enabling technologies are not limited to the area of substantive criminal law. We are also facing quite many challenging questions in the area of procedural criminal law. This has to do with automation in the area of law enforcement, with predictive policing being a quite representative example here. AI-generated evidence where consumer products, including, of course, robots, may produce a certain output that will be useful to be presented in a criminal trial. And last but not least, when an AI-enabled software does provide us information about the risk profile of a suspect, of an accused person, and several other examples. Today's presentation is rather focusing on the first layer of problems, the ones that have to do with substantive criminal law and criminal liability in particular. And here we have several challenges. To begin with, there is no such a thing as an independent legal personhood in the shape of a robot. Of course, there has been such a debate on ascribing liability to non-human actors, even starting with companies themselves, namely legal persons. But this debate is handled in a completely different way within and outside the realm of criminal law. So particularly when it comes to AI systems and robots, there is no such debate in the area of criminal law as to whether we should penalize the robot itself, even if there have been some quite extreme proposals like turning off the computer would be considered a penalty for the robot itself. What comes next? From the moment that there is no legal personhood, there is also no criminal liability scheme designed for AI systems as such. At the same time, in the majority of national legal orders, there are no specific offenses for those illegal acts that are committed either through or against an AI system and a robot as such, or with respect to designing such systems, developing them, training them, producing them, using them, and so on and so forth. With that respect, and if we have people in the audience that are quite passionate about criminal law, I would suggest that you have a look at the comparative studies released as part of a project of the International Association of Penal Law about how its legal order addresses those two topics. So if there are no specific offenses, if there is no criminal liability scheme, what is remaining to be discussed is whether the relevant criminal conduct that may also take the form of a data breach that under specific circumstances is a criminal offense can be addressed by means of existing criminal offenses. When it comes to crimes committed against an AI system, including, of course, robots, we may find resort to provisions on attacks against information systems. And why is that? Because information systems are defined in a broad way that will also absorb AI systems and robots. When it comes to crimes committed through such a system, we could employ provisions that do not specify the means used to commit a crime. This is quite usual if you take the average penal code of a national legal order. This is, for instance, the case with a provision that typifies homicide, bodily assaults, and so on and so forth. All provisions that do specify the means for committing a crime, but when they're doing so, they do refer to a computer or an information system, like computer fraud. So those are the two main avenues if we decide to employ the existing provisions of penal codes. But even if this is the case, there is one more question that we need to address. There is one more challenge that we need to face, and this has to do with the applicability of traditional criminal law categories to AI and robotics-related offenses. Of course, given the limited time that I have at my disposal, I'm not going to go through all the different challenges that have been pinpointed in the scholarship or all the different scholarly opinions that have been supported with this regard in the scholarship, but I have selected a couple of them that are of quite central importance. To begin with, the fundamental distinction between crimes committed by intention and crimes committed by negligence. In the first category, in theory, our problems wouldn't be that great. If we have somebody who intentionally manipulates a robot, intentionally manipulates the data set that the robot is provided with in order to use it, metaphorically speaking, as a weapon to commit a crime. More problematic is the category of crimes committed by negligence, where our offender needs to be able to at least foresee that his behavior could cause not any result, but a specific result, although from a subjective point of view, he does not accept that specific result and may have wished to avoid it. But no matter if the focal point becomes the intention or the negligence, still there is a cognitive element that must be there. Namely, our offender needs to be aware of the AI systems or the robot's modus operandi, at least to such an extent that makes him capable of foreseeing, predicting the causation of the typified result, for instance, the loss of human life or the bodily integrity violation that results by his or her conduct. What comes next? If we are talking about foreseeability, the result must be predictable itself. And this predictability is something that is often challenged by the nature of the system in place. And of course, I'm not going to enter into the debate about the black box. You're a specialized audience and you have already heard about it. The problem that arises in the realm of criminal law is whether lack of predictability eliminates or should eliminate what we call mens rea for those that are involved in the production of those systems, in the programming, the training of those systems, or even in the use of those systems. Of course, there are some cases in which predictability wouldn't be much of an issue, and those are the cases where the person that is to be held accountable while monitoring the function of a system was able to notice that there has been a problem, there has been a dangerous discrepancy, and he has to intervene in order to interrupt the operation of the system and avoid the criminal result. But look, here we are entering the zone of criminal liability on the grounds of omission, which means that this specific duty of action, namely the duty to intervene and interrupt the operation of the system, must be prescribed in law for criminal liability to be established. So here we are entering, the real waters of criminal liability. Next, I have already shared during the introduction that agile production is one of the key issues, of the key topics that this consortium has been working on. And I'm sure that you have talked about the involvement of several individuals during the production of such products. This interaction of several people, the involvement of several people already means that there may be certain flaws that are not recognizable by every single individual involved in the chain of production. And this already means that those individuals may also not be expected to fix those flaws. This, of course, becomes even more problematic for those who have acted in the first place. And why is that? Because their liability cannot be excluded by definition if there is a causal link between their conduct and the harmful result. There is also the particularly case of the users, and why is that? Because in their case, the focus rather lies on their failure to follow the guidelines of the producer or their intervention in the programming of the system in a non-authorized way. Having said that, let me also turn the spotlight onto the last challenge that I chose to present today, and this has to do with the standard of care. And why is that? Because usually in the realm of criminal law, we would rely, in order to define the standard of care, to the so-called general safety rules for technical products. And the question is whether such rules exist or will soon exist with regard to robots, and not any robots in general. This wouldn't say anything to anyone, but robots that are employed in a specific sector, in a specific area of activity. And when it comes to the subjective element of negligence, we are also looking for the standard of care that corresponds to whom. And this is a great challenge when we are talking about criminal liability in AI times. Is it about the standard of care that corresponds to the average designer, the average programmer, the average user of a robot? And the question is, does such a thing exist? Maybe it's going to exist in the coming years, but for the moment, it's not easy to refer to the average user of a robot. And the alternative to that will be another way to say the standard of care. This is basically an idea supported in the criminal law doctrine that has to do with the maximum care that the protection of the specific legal interest may be life, bodily integrity, privacy, and so on and so forth requires under the given circumstances. What comes next? If those are the challenges, what should be the expected reaction on the part of the legislator? Should he try to adapt the existing rules in place in order to meet those challenges by means of regulation, or should let things as they are? Here we have, in principle, two ways to address things, I repeat, in the realm of criminal law. The first idea supported in the scholarship has to do with the introduction of new endangerment offenses. This will mean that we are going to choose to criminalize the establishment or the maintenance of a specific functional source of danger that will pose a risk to legal interests that we chose to protect by means of criminal law through an AI system. This, in simpler words, mean that we may choose to penalize the production of a certain type of robots, or the training of a certain type of robots, again, with a specific data set, and so on and so forth. But here we are entering a zone that is quite delicate in terms of the details that actually matter in terms of typification. And this leads to a question that is quite prototypical in the realm of criminal law as to whether this kind of legislative intervention would comply with the fragmentary nature of criminal law. This is a principle according to which criminal law shouldn't actually be employed to address all possible conflicts that a society has to address. And of course, it also leads to a much wider debate as to how much risk we may tolerate in using AI systems and robots, and of course, as to whether criminalization may even hinder innovation, may even serve as an obstacle for future designers, producers, and so on and so forth. The second way to address things is through the lens of another doctrine, the doctrine of permissible risks. Those usually are prescribed expressly in law, and the approach that is followed is a sector-specific approach. And this doctrine indicates that we as a society, we have accepted that some risks are part of our daily life. This is why we are still driving cars, and we shouldn't employ criminal laws in order to address those risks unless violation of the violation of a legal interest or the endangerment of a legal interest takes a specific form. This is why we do not penalize the production of cars. So in this environment, in such an environment, the victim is expected to bear the harm without redress. At the moment, one may say that we do not have such rules in place when it comes to AI systems and robots, namely rules that indicate which risk is permissible or not. And I'm saying at the moment because, of course, the adoption of the EU AI Act is under portas. More regulations, either in the form of hard law or soft law, will soon be adopted in order to define the zone of permissible risk when it comes to AI production. In any event, and while awaiting for the adoption of those rules, what we need, of course, is a case-by-case exercise, balancing exercise, which will, on the one side, take into account the advantages that are associated with the development, the use, etc., of an AI system, and the harm that is inflicted upon a certain legal interest, again, may it be privacy or even human life. The question is, when the time arrives and we have those rules in place and we find which areas of activity should deserve the attention of the criminal legislator, whether the respective regulations should take place at national or EU level. And this is the last topic that I want to address by means of this keynote. If we decide to do this at EU level, considering that there is already a draft directive on civil liability for AI in the times of AI, shouldn't be a directive on criminal liability in AI times. And the question here is, which will be the proper legal basis for doing so? We should look at Article 83 of the Treaty on the Functioning of the EU. Of course, paragraph 1 wouldn't be ideal, considering that AI offenses, robot-related offenses, are not listed as Euro crimes. This means that we should look at paragraph 2 that requires, in order to employ means of criminal law, that there are already other means of harmonization in a certain area of activity, may it be, in our case, that of robotics, and there is a lack of effective implementation of the rules in place required. So, as you already understand, this requires that we spend a couple of time monitoring how those rules are employed to see if there is actually a lack of effective implementation, and then we may decide to employ criminal law. To do so, still there are some other requirements that need to be taken into consideration. We must still talk about serious crime and crime that has cross-border dimensions. And while considering penalization in this area, also make sure that our initiatives comply with the principle of subsidiarity, which means that the EU legislator should only intervene if regulation at national or regional level is not satisfactory, is not enough to achieve the same target. And to conclude, as far as I am concerned, a rather rhetorical question, what about the alternative? Should we leave criminal liability unregulated? And my answer will be, well, better not. Of course, we need to monitor things and see how those evolve. But once AI systems and robots become an actual part of our daily lives, we will soon have to face that harmful results or other dangers may be associated with their use and their development. And those harms and those dangers may even be equivalent to grave violations of fundamental rights. So for the moment, and as far as criminal liability is concerned, of course, we are alerted, we are monitoring things. And I have to admit that the adoption of the EU AI Act, even if the text itself has little to do with criminal law, is much awaited for the next steps in our areas. Thank you very much.
Thank you so much. And we now have some time also for questions from the audience. It's a very interesting topic, of course, and a very interesting speech. So thank you again. And if you have any comments or questions, feel free to leave them in the chat or also to raise your hand and we can ask you to unmute yourself. If there's anyone.
I have a question, Sylvia. This is Winston Maxwell. I was wondering whether the current situation is that I think if a machine kills a worker in a factory, I think in French law at least, there would be a presumption of a very serious safety fault by the employer, and the employer would likely incur some sort of criminal liability just under current law, because the employer has a duty of care to keep a safe workplace. And I'm wondering how AI, where machines are more autonomous, if that would change the current way we think about employer liability for serious injuries or death.
Thank you very much for this question. And I have to admit that I'm also really happy that we are sharing the floor as keynote speakers in this workshop, since I have the pleasure to attend several presentations of yours in the past. This is a very reasonable question, and this also reflects some criticism that we also encounter in the scholarship as to whether things need to change or not. And this has to do, of course, with the question of whether we are going to have a third autonomous player that we need to take into consideration as regards the interaction between robots and humans or not. I believe that the scholarship already developed in the area of autonomous vehicles is quite telling here, because we need to take into account the different levels of autonomy. For instance, if we are talking about examples where the driver can always take the control of the vehicle and respond based on his capabilities, based on his experience, it wouldn't be easy to argue that we are going to need new rules in place in order to decide on criminal liability. So, of course, we need to be very cautious when we are discussing about regulation, not just because autonomy may not be of such a great level to change things, but also because we are talking about crimes that belong to the core of criminal law. And I guess your example has been a random one because you used the example of homicide. So, of course, we wouldn't need to redefine things that are pretty much established, and even in terms of their phenomenology are not going to change much. What we need to study closer, this is why this discussion is way more related to the general part of criminal law than the special part thereof. So whether something needs to change as to the way that we perceive liability and interaction. What, of course, at least for the ones trained in a continental European system is of critical importance, is that we do not find our way towards accepting objective liability. This is something that we avoided in the past when we were discussing corporate criminal liability, and it seems that it's a topic that is surfacing again in the environment of the interaction between humans and robots.
Thank you so much. I don't see any other question, and maybe I will just pose one myself, actually. That came to me while during your speech. I was wondering, especially thinking about today's topic and the context. I was a little bit curious when you mentioned the idea of the permissible risk as a solution. But in the context of Agile production, at least, it's an area in which the decision to implement a robotic system usually comes from the management, and then the people interacting with it are the workers underneath. So I wonder, in that case, what could be maybe, like, what would you think could be a good balance between regulation and the permissible risk in that case, in which the person taking the risk is not the person actually being affected by the robotic system?
Okay, let me clarify here that the doctrine of permissible risk is not employed in order to solve liability queries that arise in the environment of agile production and have to do with the delegation of several tasks and this bottom-down approach to production, but rather has to do with the more central decision of a society as to produce a certain robot or AI system, as to merchandise such a robot or an AI system in general. This is why I use the example of the production of cars. So permissible risk will not address the question as to whether the manager delegated correctly or not this or that task to a robot or a human agent, but it rather addresses the question of whether this product itself poses a danger to the society that is not to be tolerated.
Okay, I see. Thank you. Then I understand a little bit better. And I see a comment in the chat by Muhammad, who asks, up to what extent the permissible risks are adopted or allowed to continue unless they become most dangerous? So I don't know if I interpret the question correctly, but I think that it's about the kind of risk level that it's allowed even within the doctrine of permissible risk, and when something becomes to be considered dangerous and when not.
Well, I guess that the answer to this question was already hidden in my very first slide, that law is dynamic by nature. So, of course, we cannot predefine the level of the risk that we accept as a society, on day one, and never revisit this decision based on how technology is evolving. But it's also important to stress that the notion of permissible risk can be used in a twofold way. First, in order to decide to abstain from regulation, and second, in order to decide to waive liability. For instance, permissible risk is used a lot in the area of medical practice, signaling that this particular conduct is defined as unlawful a priori, but under the given circumstances, liability is to be waived in the name of the permissible risk.
Okay, thank you so much, Atina. And Malcolm Fisk, I see you have your hand raised.
Yeah, this is possibly more an observation than a question, but I'd be interested in some comment. And Athena just mentioned medical care, healthcare, as some of you will know, is my focal interest. And when it comes to the issue of AI and medical treatments and diagnoses and things like this, then there's a whole raft, of course, of levels of liability that already apply in various medical regulations, and which impact on consultants and doctors and nurses and all the rest of it. I mean, it just adds, I don't know, I mean, it's already complex, but this adds further layers of complexity. And I wonder if Athena would just like to comment on that, and or especially in the case, in the context that we have, where more people are using technologies directly rather than necessarily being provided with them, and therefore being directly vulnerable to whatever potential risks might arise from AI, especially in the context of machine learning, where even the GPs and the consultants consultants don't necessarily understand why a particular course of treatment perhaps is being recommended, or a particular outcome or diagnosis is made, and therefore cannot explain it to the patient for whom they have direct responsibility. So any comments? I mean, I know there's not a lot of answers yet, but any comment would be very, very welcomed, Athena. Thank you.
This is a great observation, actually, and it makes me think that in different academic events that have to do with automation, digitalization, and law, sometimes we feel that we are perfect at describing the problem and clearly not able to identify the right solutions to them. The examples that you mentioned are quite telling. I was thinking that you mentioned, for instance, that a GP may not even be able to describe the tools that he's employing or the method of diagnosis, which means how on earth we can talk about informed consent on the part of the patient if this kind of explanation is missing in the first place. So my reaction to that will be that the answers that we are looking for, at least not all of them, are hidden in regulation and law, because basically, based on the examples that you gave, some solutions are to be sought in the area of education before we start employing all those new technologies, especially in critical areas like the one of medical practice.
Yes, thank you so much. And I think it's a very interesting discussion. There's, as you said, a lot of maybe questions, and then coming up with answers. It's one of the aims of the Robotics for You project. So we hope that also this can help, like having these discussions already. Thank you again for the keynote speech. And I don't know if you will be able to stay with us for the discussion later. If yes, you're very welcome. And if not, thank you for participating and giving this very good presentation. And I will now move on to our next keynote speaker. Yes, Professor Maxwell, the floor is yours. Professor Maxwell is Director of Law and Technology Studies at Télécom Paris, Institut Polytechnique de Paris. And he is going to give us today a talk about effective human oversight of AI systems. So we are moving maybe a little bit also into the solutions already, and key enablers and obstacles.
Okay, thank you, Ilka. I'll share my screen. Okay. So I will talk to you about human oversight and human control. Let me say, though, that I'm very happy to respond to questions more specifically about the GDPR and Agile Production. I've looked at, thanks to Sylvia, I've looked at some of the use cases, and some of the use cases involve predicting human movements, for example, on a factory floor. And you can imagine that those systems of image recognition and smart video will be processing personal data, and it may be considered even biometric data because the system is able to identify employee X or employee Y and know what he or she is doing and predict his or her movements so as to better plan agile production. So that raises a lot of issues under the GDPR and under the AI Act. But my focus today is on a subject of research that I've worked on for the last couple of years about human control or human oversight of AI systems. And there is a link with the GDPR, which I'll get to in a minute. But first of all, I thought it'd be useful to make a diagram to sort of illustrate a agile production environment where you have machines and you have humans, and all that is linked with sensors to artificial intelligence, which is designed to maximize efficiency on the shop floor And then you have a human supervisor who's overseeing the system. And the question is, well, what is that supervisor supposed to do? A human supervisor is, essential under the AI Act and under a lot of AI ethics documents. But what is she supposed to do, and how do we measure her success, her KPIs? Exactly. So that's the subject I looked into. And the first stop is to say, well, what if anything does the Future AI Act say about that? Well, it says that human oversight is required for any high-risk AI systems. And I understand you've had presentations about the AI Act, so I won't tell you about high risk versus non-high risk. And the objective of human supervision is to prevent, minimize risks to health, safety, or fundamental rights. And all this makes a lot of sense. What are the requirements of a human overseer or human oversight function? Well, the person in charge of human oversight must first understand the system limitations so as to be able to detect anomalies, dysfunctions, and unexpected performance. So he or she has to be trained, has to understand the vulnerabilities of the system, the likely errors that may come up, what she should be looking for. The human supervisor needs to be trained also about automation bias, and we'll get back to that. That's a human cognitive bias, which leads us to give undue weight to algorithmic recommendations, sort of under the assumption that the AI system must be smarter than I am, so who am I to contradict it? The human supervisor must be able to correctly interpret system output. And again, that's linked to the overseer's understanding of the system. The human supervisor must be able to override the system decisions and press a stop button. This is very intuitive, right? We expect the person in the image we saw a minute ago to have a big stop button next to her in case something goes wrong. So let's think of some things that might go wrong and that might require human intervention. Well, of course, you have the classic examples of a sensor is not functioning right, and so it doesn't see someone on the shop floor, and therefore the machine is engaging in a dangerous activity too near to a human. And so the human supervisor needs to be able to anticipate that kind of failure. We'll come back to this, but the AI system may recommend something that seems wrong. Like, we want to shut down one line of production because we think we need scheduled maintenance. And then the human supervisor says, well, that doesn't make sense. We had maintenance last week. There's something wrong about that. I need to look into it. In terms of human rights and GDPR, another thing that we expect the human supervisor to do is to detect when there may be violations of individual rights. And on the shop floor, in Agile Production, you could imagine that although the AI system is not engineered to discriminate, it may actually indirectly discriminate against certain people. For example, people who walk in a certain way, the system may not be able to predict his or her movements because of a handicap or because of the person is old. The system maybe was trained on a certain kind of people who move in a certain way. And so when other kinds of people are analyzed, the system doesn't work as well. And those are very difficult discriminatory biases to detect. So what are the kinds of oversight? What are the modalities of human control and human oversight? There are, of course, many, but I've simplified into three types. The first one, I'll go into each one in a second, but the first one is human on the loop, which basically you have the human supervisor who's watching the system and has a stop button ready in case something goes wrong. The second is human in the loop, which is the human actually has to validate a decision before it is made. For certain important decisions, like we think worker X should be moved from this area of the factory to another one. It may be that a human needs to validate that because we don't want to have human beings dealt with through purely algorithmic recommendations, or maybe another important decision about reducing production in one of the units, and you don't want the machine to make that decision all by itself. The third is human verification after the fact. And this often comes up when you're trying to determine why something went wrong, or you're trying to deal with a complaint. A worker feels that she was badly treated and is not given as good opportunities as somebody else, and wants to challenge the decision. So let's look at each of these modalities of human control and think about the obstacles, because there are many, many obstacles to effective human oversight. The first one is human on the loop. So the idea is that you have a human who is sort of the guardian of the safety of the system and is able to intervene in case something goes wrong. The best example of that is this Uber crash that killed a pedestrian in Arizona. The analysis after the crash showed that the human whose job was to intervene in case of an emergency was actually watching a video on her smartphone, and therefore when the alarm went off, now there was also problems with the image recognition system, which misclassified the object in the road. But when the alarm went off, it was too late for the driver to kind of get back his cognitive connection. That's called the human out of the loop problem. And that's very, very well studied in aeronautics. You know, automatic pilots, the Air Safety Administrations have been looking at this because in case of an emergency in an aircraft, human pilots are supposed to take control, but they've studied it and they've shown that, you know, after 30 minutes of doing nothing, the human mind naturally disconnects. And to get reconnected with the situation, it takes between 10 and 30 seconds for the human to kind of say, oh, what's going on? So that's why in many cases, whether it's driving a train or an aircraft, the system is designed actually to keep the human on the loop person busy doing stuff and engaged, even artificially, so that every so many minutes, the pilot actually has to do something. And there's lots of literature, and it's very, very interesting about how, you know, it's really pointless to kind of put a human on the loop and expect the human to intervene to prevent an accident when we know that a human being naturally gets bored and the brain just kind of drifts off after a certain amount of inactivity. Now, what about human in the loop, where we want a human to intervene and validate results? There too, we have many, many problems. It sounds nice on paper, and the GDPR even refers to the right to a human intervention as if it were a cure to any possible harm. Well, it's not that easy. A number of studies have shown that, you know, the human will suffer from alert fatigue, information overload. He or she will feel pointless. There's a tendency to give too much confidence to AI results. I put an image of doctors here. Malcolm Fisk will know about this, but Even doctors, studies have shown that you want the human to make his or her diagnosis independently before seeing what the AI says. Because often, whether we like it or not, we are unconsciously pushed to agree with the algorithmic recommendations. That's also because of the way our liability is structured, and that's very close to the previous speaker's comments. If I'm a doctor and I disagree with a treatment recommendation of the AI, there's been literature talking about this. Actually, my risk of being at fault if something goes wrong is higher than if I agree with the algorithmic output. So I have a natural tendency saying, well, this AI system's been tested, and statistically it is better than humans. Otherwise, it wouldn't be on the market. So if I'm disagreeing, I'm really taking a risk. And in that connection, you could say, well, explainability is kind of the cure, but it's not actually. In the field of cognitive sciences, we found that explainability actually increases overconfidence. If you explain an algorithmic recommendation, the person reading it will have even more tendency to trust the algorithmic results, sometimes even when the results are wrong. So you have to be careful about explainability as the cure to this automation bias. Okay, what about the role of humans verifying things after the fact? So we see the human supervisor wondering, there are clues that this AI agile production system seems to be discriminating against female workers. How can I investigate that? How can I be sure if that's true or not? Or the AI is recommending that we decrease production, and that intuitively doesn't sound right. And there we run across something that was mentioned previously as well, which is the opacity of many machine learning models, which is a real dilemma because sometimes neural networks are the best prediction tool, but because they are black box, they sometimes are abandoned or not used for critical applications. And I don't know how agile production software, what the choices are there, but in many critical contexts, you just don't want to use a black box model at all because of the probabilistic nature of it, and because you can never really know why it made a certain recommendation. You can guess, and there are methods to guess called explainability, XAI, explainable AI, but you can never be sure. There's another aspect of human oversight that is linked to the GDPR and fundamental rights, and also to worker rights if we're talking about agile production, which is a consensus that when we're dealing with when we're dealing with humans and having a decision about humans, the decision about whether to change a worker from unit A to unit B should be made by a human and not by a machine. That decision should be contestable. That's an important term in human rights. That somebody affected by a decision should be able to contest it. Go to the boss, go to the supervisor, and say, "I don't understand. That doesn't seem fair. I've been performing just as well as other people. Why?" And then there's supposed to be a human-to-human discussion and the ability to give reasons and defend oneself. And this has come up in it's not on the agile production field, but it's in the platform workers directive, the proposed directive that would govern algorithms that deal with workers in the so-called gig economy. That's what the directive says, that if there's an algorithmic decision made that affects how that worker is ranked or how they're treated or what jobs they get, the worker needs to be able to discuss that with a human representative of the platform. These are references on that. And then we have the question of liability. Just checking the time. I'll wrap this up in a second. Human oversight is part of accountability, and so it's under the AI Act and under the GDPR, you have to put in effective organizational measures to ensure that the GDPR is complied with, and also the AI Act, that the system is operating under appropriate supervision. So having a human on the loop or in the loop is part of your general obligation to be accountable and have good responsibility in the organization. And that requires also, accountability requires that you allocate responsibilities in the organization to different people. And we then fall into a trap, which is outlined in some of the literature, which is the human in the loop or human on the loop can easily turn into a scapegoat for liability. And that was evidenced in the Uber crash that killed the pedestrian. The driver, sure, the driver was negligent, but the driver was pleaded guilty to a criminal charge of homicide, unintentional homicide, and was really the most penalized of all. And even though Uber, I think, has civil liability, but we have to be very careful about giving too much responsibility to the human oversight person because of all the problems we saw. Someone in charge of human control can't do everything. And that leads me to my last slide, which is, it's totally unrealistic to ask a human to verify and do the same task as the computer, saying, okay, do you agree with what the AI just recommended for this production line? That's an impossible task for the human to be able to say, well, yeah, I think I agree. So the secret, pointed out by some authors, is to make sure that when you have a human supervisor, you ask that human to do a discrete task that is different from the task of the computer. So you ask the human supervisor, for example, to compare the AI recommendation maybe with the employee records or something, but something distinct from what the computer does. Because otherwise, if the human feels that he or she is doing the same thing as a computer, he or she will become completely demotivated and disconnected. It's an impossible task. And then you need to carefully study human cognitive biases. You need to test them, just like an aircraft pilot, and then compensate for them for whatever mechanism you have, by making sure that the human supervisor has to undertake some tasks every 5 minutes to stay alert, or make sure that the responsibilities are divided among several different supervisors. That's references on those points. So thank you very much. I'll stop sharing and we can discuss if you like.
Thank you so much. Very interesting presentation as well. And I'll just open right away for questions or comments from the audience. Very clear also, I have to say. It was very nice to see it so well divided and the challenges so well explained. So thank you for that. Yes, Athena, please.
Thank you, Sylvia. A brilliant presentation indeed. I have a question. that arose due to my background in the studies of liability in corporate environments. And I was wondering to what extent we could associate your three key takeaways with what we call corporate culture, and then shape liability upon this basis.
Well, in most big corporations have very extensive, I'm thinking of banking, for example. In banking, there are very extensive internal controls, especially since the 2008 banking crisis. So you have what they call level 1 line of defense, level 2 line of defense, and level 3 line of defense, with each level supervising or auditing or reviewing what the level below does. And so in corporate culture and compliance, we're beginning to become very accustomed to these internal controls. And so what the AI Act envisages about human oversight and risk management systems, which is what they say, fits very well into the established compliance controls and quality controls of many large corporations. So I sort of view it as the same thing, that it's just that AI would be another critical field that would have to be integrated into these internal controls. And GDPR is already part. You have to have internal controls for GDPR compliance with a data protection officer and data protection impact assessments. So AI is just going to be another brick in that big house of internal controls.
Thank you so much. Let me see, I see some comments in the chat. So a comment from Muhammad that I can read. It's sorry. Mr. Maxwell research is inspiring and motivating to explore more threefold loopholes in the AI Agile production and discussing the case study for better outcomes and accurate decision of AI. Indeed, it's very interesting in the context of Agile production, where especially it's a lot of human and robot interaction and already what is oversight. I think it could also be interesting to discuss what is human oversight in that context, where it's this collaboration between the two. And Wendy Chang also asks, who are your key customers? I'm not sure actually that it's a relevant question, but I don't know if you have comments on Muhammad comments actually on the specifics of the outcomes and accurate decisions of AI for the Agile production.
Well, as I told Sylvia on the phone last week, I'm not specialized in Industry 4.0 and AI for production, which is a very important field. It's just that I haven't focused too much on it. And I've worked a lot on image recognition, AI decisions for criminal detection of crime and things like this. So I had to, I don't have a very deep vision of agile production use cases. But Sylvia helped me a little bit understand that often agile production involves coordinating human and machine behavior and including predicting human movements. And that reminded me of our work in image recognition, and including image recognition for threats to public security, like in the Paris Olympic Games. They have a proposed law that would, well, it's a law now, it's been voted, that would allow deployment of smart video, which basically analyzes movements to detect suspicious or dangerous situations. And that was subject to a great deal of debate because there's fear that that could be the first step to kind of a massive surveillance society of tracking everybody in public spaces. But in the context of looking at that smart video application, we realized how discriminations can occur just because any sort of image computer vision application suffers from biases. And the biases may be between males and females, it may be between people with different, the way they dress differently or the way they walk. The way the system is trained will do very well for some types of people, but if it's not trained on other types of people. So I sort of projected that into the agile production space and said, well, okay, that sounds like that sort of bias could also manifest itself in agile production if the system is able to predict some workers' behavior and movements very well, and for others it doesn't do so well, simply because there's a bias in the training data or in the algorithm itself. Sorry, I got off on another subject a little bit, but that's what I thought of when you were talking about agile production.
And we have seen actually some cases in previous events of robots being biased in that sense against determined categories. We have 2 more questions in the chat. I will only take one as we don't have much time anymore. And Berke had a question about open source AI, but if it's okay, Berke, we will discuss that in the breakout rooms later. So I think that I will make sure that you are in the breakout room discussing this specific topic, so that you can discuss it more with the participants. But then one interesting question from Adgiro Amidi, if I pronounced the name correctly, which is that before artificial intelligence and robots, at the end of the day, it was human responsibility. So why worrying about not putting much responsibility upon the human shoulders now?
Yeah, that's a good point. The articles that talk about this scapegoat type phenomenon, I think, are not so much to avoid responsibility. I think people who supervise and oversee AI acknowledge that they'll have responsibility. It's just that responsibility has to be linked to linked with an assessment of the person's real capabilities to actually do what she is supposed to do. So, it's like asking one supervisor before AI, let's just say we have one supervisor who's standing on a balcony and looking over a shop floor that has, 2,000 meters with 1,000 workers. You say, okay, well, that person's in charge of making sure everything's running safely. That's impossible. We would all agree that that's impossible. That job is just asking for trouble. And so it's the same thing for AI. You just want to be careful that you don't have the illusion that a single person can detect things like discrimination or dangerous situations all by herself. And you have to just investigate case by case, what task is appropriate to give to that person and what responsibilities go with that task.
Yeah, thank you. That's a very good point, I think, to allocate responsibility also in a realistic way. Thank you so much again for participating and giving this very, very interesting keynote speech, both to Professor Maxwell and also to Professor Sacolido. And I will now move on to the presentation of the RoboCompass. If Anne Kalugina, I saw her joining the call earlier, is ready.
Yes. Can you hear me?
Would you?
Okay, you can't see me.
Yeah, exactly.
Yeah,
Okay, now
better.
we can
Okay.
see you.
Okay, so I will share my screen.
You have until 25 past.
Oh, okay. So I will be quick. Start the presentation. Okay, oh, I can't share my screen. Can you allow me?
Yeah. Can you make your co-host? Is that working now? Yeah.
Oh, yes. Okay, great. So can you see it?
Yes, now we can see.
Okay, great. So I will try to be brief. The Responsible Robotics Compass is a tool that we developed in the Robotics for You project that aims to that is developed for the robot manufacturers. The goal of the tool is to help the manufacturers to measure whether the robot is sustainable, what could be the barriers to its acceptance by society, what steps the manufacturer could take to improve the sustainability and the acceptability of the robot. Sorry? No? Okay, so for this tool, we have looked at non-technological barriers to robot adoption, and we have classified them into 5 large areas: so environment, socioeconomics, legal, data, and human experience. We try to be to classify all issues, so to be both exhaustive and not to have any overlap between the issues. In more detail, that is how the categories are detailed. So for example, for data, since that is the topic for today, we are looking at the issues based on collection of data. So how can you minimize the data that is collected by the robot? How can you make it known to the user which data is being collected? For example, you could angle the cameras in a way that the faces of people are not visible. In that way, you are minimizing the collection of sensible data. The storage, how is it stored? Where is it stored? Who has access to this data? The usage, how is it going to be used for training? Is it going to be used for evaluation of performance? Stuff like this, and the use of external data, for example, for training of AI algorithms. What is the ownership of this data? What is its origin? Has it been controlled for biases? And also, how is it handled in terms of security? So that's, for example, just detailing one of these sections. For each of the sections, we are trying to look exhaustively at different aspects of this issue. The tool works as a self-assessment grid where you assess on one side the risks based for one category and the mitigation steps that you have already taken. And at the end, you obtain a report, you obtain a scoring, so saying how good you are doing in each category. For example, here we have a global assessment where we have in the environmental issues, the score is not so good, but for the legal, it's nearly perfect. The risks are very low and nearly all the mitigation steps were taken. So the idea is just in one image, you see how you are doing in different categories, and you know which ones are most important for you, for your robot. And also the idea is to be able to take this assessment repeatedly and see how your scores are evolving in time. So during the development, we also provide some resources in the final report to help you improve your robot and improve its acceptability. And regarding the timeline, we have been developing this tool since 2020, and right now the second version of the tool is live. You can test it at robocompass.robotics4u.eu. And you can give us your feedback. If you are a robot manufacturer, we are happy to discuss it with you if you want to have a call. And also, if you are not a robot manufacturer, but you want to give us some feedback, it is always open. There is a form, but you can send us an email. We are always happy to discuss it. So thank you. I hope I wasn't too long.
That's perfect. Thank you so
Great.
much. Lucas?
Yeah, I just quickly want to add here, because I think it's important for those who are listening in right now, is that the purpose here is to make the tool grow by the community. So we allow for self-identification of their own risks or mitigation steps that haven't been mentioned before. We record that, and if we see that something has been mentioned more than 5 times, we can include it into the tool. And this allows for research or new findings or new risks or new way to mitigate things to really enter the best practices very fast and very, very quickly. So we fasten the speed, how fast the research is being adopted in practice.
Mm-hmm.
The same goes for policies.
Yes, thank you.
So, and we'll be staying after the presentation.
If you have any questions, me and Lucas, we can answer them.
Yes, thank you so much, Anne and Lucas. And we will now move on into breakout rooms for the discussion. But as Lucas said, the discussion in the breakout rooms will be more or less until 3:50. But if you want to discuss more and want to stay a little bit more after that, we will come back to the main session, but we can stay also a little bit after 4 if you have time to stay. But now I will open the breakout rooms, and in the breakout rooms, we will gather your feedback on the specific questions of the RoboCompass, so you will be able to give us your opinion on the RoboCompass specifically.
Thank you.